Hello, welcome to the video notes for lesson 1-1. The first lesson in topic 1, which I know seems kind of weird, because here we are near the end of the school year, and we're just doing the first topic. But as you know, we've been going out of order all year long. So this first lesson is about decimals and fractions, which many of you have probably had quite a bit of experience with, but we're going to explore it a lot more and understand it much more and get a lot more complicated with it. Alright, so let's take a look at the lesson targets or the learning targets. I can transform a decimal into fraction form, so we'll be converting decimals to fractions. And then I can transform a fraction into decimal form. So take fractions and turn them into decimals. Decimals to fractions, fractions to decimals. Alright? So, and I bet some of you have had plenty of experience with that. So this should be almost like review for you. But again, we'll be dealing with much more complicated forms. One thing I want to point out, when we do decimal form, we will be, if there's no number in front of the decimal, I want you to get in the habit of start with a 0 in front of the decimal. So, when we have a fraction like 1/2 and we convert it to a decimal, a lot of you will just say 0.5. I want you to get in the habit of knowing it's 0.5. Alright, so, what are we working with? Well, we're talking about rational numbers. Alright? That's a big idea here. A rational number is a number that can be written in the form of a over b. In other words, as a fraction, where a and b are integers and b is not 0. Remember, you can't have 0 on the bottom. If you do, try to plug that into your calculator. Your calculator doesn't like it. We can't divide by or have 0 in the denominator. Okay, rational numbers can also be written in decimal form. So besides the fraction, it can be written in decimal form. Think of a over b as a fraction. To write a over b as a decimal, you divide a divided by b. Alright? So a divided by b. Or, if we're thinking of long division, the top dog in the doghouse, so the numerator goes inside, b goes on the outside, and we do our long division to find our decimal. Alright? A rational number in decimal form is either terminating or a repeating decimal. Now, when I say terminating, you need to understand what that means. Terminating means it ends. If something is terminated, it ends or it stops. Alright? Repeating means we have a repeating pattern, like 0.3333 repeating. A terminating decimal has a decimal expansion that terminates in zeros. In other words, we get to a point where the only thing that would come after it is zeros. All integers can be written with a 0 following a decimal point. So all integers are terminating decimals. Remember, the word terminating means it ends. So if I'm looking at like 9 over 5, 9/5, that equals to 1.8. If I were to write the number that comes after the 8, it's a 0. And everything after is a 0. So that's why it's terminating. Same thing with all of these. Notice the number 5 is the same as 5 over 1 or 5.0. Alright? So if it ends in a 0 and there's nothing else after, it is terminating. Okay? Alright, so let's take a look at the other examples at the bottom about repeating decimals. A repeating decimal has a decimal expansion that repeats the same digit or block of digits without end. A bar indicates a repeating digit, a bar over the number, or a block of digits. So 0.3 repeating with a 3 over, or a bar over the 3 means the 3 is the repeated digit. So 1/3 is 0.3 repeating, so I put a bar over the 3. -4/9 is -0.4 repeating, so I put a bar over the 4. 7/15 is 0.46, only the 6 is repeating. So I just put a bar over the 6, not over the 4. You got to be careful with that. And then 49/33 turns into 1.484848. The 4 and the 8 repeat, so you have to have a bar over both. All right? Good stuff. All right, so over on the next page, page 2, we're going to express fractions as decimals. Is it a factor of 10 or 100? In other words, so this one is 3/4, and many of you probably know that it is the decimal 0.75. Now, if I were to say this the correct way, it's not 0.75, it's 75 hundredths. So it is a factor of 100. We could think of it as 75 over 100. In other words, the denominator 4 doesn't go into 10, it goes into 100. I can't, well, I could multiply 4 by 2.5 to get 10. But 4 times 25 gives me 100, 3 times 25 gives me 75. And this converts nicely to a decimal. 75 over 100 is 75 hundredths. 0.75 is also 75 hundredths. Another way to find this, if I take your calculator away, remember, top dog in the doghouse, so the 3 goes on the inside, 4 goes on the outside. There's a decimal behind the 3, so I bring that up, put it there. 4 goes into 3 0 times. 4 goes into 30 7 times. 4 times 7 is 28. Subtract the two numbers. You get 2, bring down another 0. 24 goes into 25 times, nicely. 20 minus 20 is 0, and we're done. We could keep adding zeros at the end, but you don't need to. All right, now, I'm not going to take your calculators away, so if you know what to do, you can just simply type in 13 divided by 20. Think of this as, now, I know you might be saying, well, 20 can be reduced to 10 by dividing by 2. Can we divide 13 by 2? It's not a bad number, but we're not looking to create a decimal within our fraction. So think of 20 going into 100. Multiply that by 5. 20 times 5 is 100. 13 times 5 is 65. 65 hundredths. If you divide 13 by 20, you get 0.65. So remember, we're putting the 0 in the front. So since it goes out 2 decimal places, this is a factor of 100. It's 100. 8 over 25, same thing. Do 8 divided by 25. 25 doesn't go into 10, but it does go into 100. Multiply it by 4. 8 times 4 is 32. 32 hundredths, or 0.32. 5 can go into 10. So this is a 10. 8. So if I multiply 5 by 2 to get 10, I do 4 times 2 to get 8. This decimal is 0.8, or 8 tenths. And then 50 goes into 100 nicely. It also goes into 10. 50 divided by 5 is 10, or multiplied by 1/5. But I can't divide 42 by 5 nicely, so I think of this as 84 over 100. 84 hundredths is written as 0.84. So I just showed you a bunch of tips to convert these to decimals nicely. Obviously, the calculator is the most useful tool, but if you don't have a calculator, you need some other tricks. You've got long division, or try to turn it into a number out of 100, out of 10, or even out of 1,000. And if you can do that, then you can write it, knowing your place value, pretty easily. All right, so the problems down below say to reduce first. And if you reduce it, sometimes it turns out really nice. So the first one I notice right away I can divide the top and the bottom by 5, and I get 9/10. Remember, 9/10 is 0.9. If I say this the correct way, it's not 0.9, it's 9/10, because 9 is in the tenths place. 8 over 32. The top and the bottom can be divided by 8, so I get 8 divided by 8, which is 1, 32 divided by 8, which is 4. 1/4. Many of you probably know what that is, so you don't even need a calculator. It's 0.25. 9 over 24. What can 9 and 24 be divided by? 3. That's right. So 9 divided by 3 is 3. 24 divided by 3 is 8. 3/8. Now, not everybody knows what 3/8 simplifies to. So you can do long division. You can try to find a nice number that 8 goes into. Does 8 go into 10? No. 100? No. But it does go into 1,000. Or, like I said, you can divide it in your calculator. 3 divided by 8. And you get 0.375, or 375 thousandths. 35 over 42, divide the top and the bottom by 7, you get 5/6. Now, here's an interesting number. You end up getting 0.83, and the 3 keeps on going. 3, dot, dot, dot. So the right way to write this is 0.83 with a line over just the 3, not the 8. If you put the line over everything, you are not going to get full credit for this on an assessment. Okay, so there is some more examples. Down at the bottom, divide using a calculator. Okay, now you got to watch out for this. I'm actually going to have you do this one on your own because it works out to be a nice one. This one, however, 5/12, when you do 5 divided by 12, you get an interesting answer. You get 0.416, and then this keeps on going to 6. And then some of you might say, oh, but the last number is a 7, so it terminates. Absolutely not. Your calculator does a bad thing. It rounds the last number because it can't keep on going, and it can't show that it keeps on going. But the 6 is repeating. So the correct way to write this, and you need to be aware of that, by the way, is 0.416 with a line over the 6 only. All right, so you're going to do this one on your own. Let's go ahead and take a look at page 3, the last few problems for this video. Comparing decimals. All right, so what I like to do is make sure the place values are the same. So I've got 4.2 or 4.18. I tell you, it's interesting how many times people will take 4.18 because there's more digits. 4.2 doesn't go out as many digits as 4.18. If there was one more number here, then I could compare them. Well, put a 0 there. So now the 4s are equal, so I can't compare them by that, but I can compare them by those numbers. And 20 is bigger than 18. So this is the greater number. Same thing here, 3.45 or 3.425. So some people are saying, oh, there's more digits. That means nothing. 3.425 goes out 3 digits, so let's do the same thing with 3.45, add a 0 at the end. 450 is bigger than 425, so this is the bigger number. Okay, the next one is comparing fractions. Now, when you have fractions, if you've got a common denominator, it's easy to compare them. 7/8, 3/4, they don't have a common denominator, but I can turn 3/4 into 6/8 by multiplying the top and the bottom by 2. And then it's pretty easy to say, well, this numerator is greater than this one, so this is the bigger number. Now, you can't always do that, or you can't always do it easily, so sometimes it makes more sense to convert these to decimals. Well, this one just happens to be a pretty rough-looking decimal, too. You end up with 5.0 5 and 4/7 is 5.571428, and all 6 of these digits are repeating. 5 and 5/11 is 5.45, and the 4 and the 5 are repeating. So since this goes out 6 digits, we could carry this out 6 digits and put a line over the last 4 or 5. And then that way we can compare 571,428 with 454545. But obviously, since this number is greater than this number, this is the bigger one, 5 and 4/7. All right, there's a few more at the bottom. We'll take a quick look at those. And this video is already getting too long, so we're going to have to wrap it up. Which number is greater, 3/8 or 0.3? Remember, 3/8 turns into 0.375. And obviously, if we have fractions and decimals mixed, we want to convert them both to fractions or convert them both to decimals. 3/8 is a fraction. 3/10 is an easy fraction. It's 3/10. But the denominators are different, so it's not easy to compare. However, any of you that are really knowledgeable about fractions know that if this is a smaller denominator and the numerators are the same, this is going to be bigger. But I always like working with the decimals because I just feel like I know my answers a little better. So 0.3 or 3/10 can become 3/1000 by putting 2 zeros at the end. And 300 is not as big as 375, so this is the bigger number, 3/8. 2 and 5/9 or 2.5. 2 and 5/9 is 2.5 with a repeating 5. So if I were to expand this out one more, it had 55. 2.5 is like 2.50. So which one is bigger, 55 or 50? And it's obviously this one. So far, the first number has been the bigger number every time. Guess what? And this one, it is not. 7/16 turns into 0.4375. We already know that 0.4 repeating is 0.4444. Notice how many 4s I wrote. I put 4 of them because there was 4 digits here. So what's bigger? 4,375 or 4,444? Obviously this one is, so that is the bigger number. All right. Lots of information in this video, but I believe many of it is going to be information you've heard before. So, if you were confused by anything, go back and rewatch the video, or come see me for help. Good luck, and we'll see you in math.